Hello and welcome to another video. This is again about amount of substance. It's an AS paper. I think it's 2016, but I'm not sure. It doesn't really matter, but it's about a metal carbonate and an acid. It's a simple acid-base titration. And what they're going to ask us to do in the end is find out the MR of this metal carbonate. Whether it'll help or not, I don't know, but it's not actually a carbonate, is it? It's a hydrogen carbonate. Now, a hydrogen carbonate has a single negative charge on it. So that means that the metal, which is represented by M, must have a charge of +1. There's no such element as M, it's just a metal. Okay, there is a metal with M in it, and that's just molybdenum, but it's not that, it's just M. We don't know what it is. Maybe we can find out. But the first thing the question wants us to do is something quite easy, which is to find the mean titer. So please don't go ahead and just add all these up and divide them by 4. We've got to be more selective than that. The first one, forget it, because it's a rough one. It even tells us that. This will be miles out. It's just to give us a rough idea of when we need to think about slowing down at the end of the titer. Now what we need is from these other 3, we need 2 concordant results. That means results that agree within 0.1. Well, there's only 2. This one and this one. That one is more than 0.1 away. The average of these 2 is 9.70. Okay, so that's the average titer. So we've done that. So what we need is the moles of HCl. I wouldn't bother rewriting the question in the exam, obviously. I'm doing it for clarity to show what I'm actually doing. Moles of HCl reacting with 25 of the sample is, well, we've got an equation for that. There's only 2. There's N equals CV and N equals M over MR. Obviously, because we're involving a volume, that's in centimeters cubed, we need to use this one. The other one's no use. And we're trying to find moles. So moles, concentration, they're giving us that, 0.102. The key to this is really remembering where the numbers are and knowing what they mean, because there's numbers everywhere. Volume, well, there's 3 volumes at least there, but the one you want, we're talking about HCl, and the titer, the average titer of HCl is 9.70. But this volume needs to be in decimeters cubed, not centimeters cubed. So we needed to divide it by 1,000, which means we moved the decimal point twice. That gives us 2 zeros. So it's 0.102 times 0.0097. That, I think, is a job for the calculator. So I will do that. If you want to try it as well, always make sure you can use your calculator fluently, quickly, and accurately. We get, or I get, 0.30 9894. That's the moles of HCl. But that's in 25. So let's look at the moles of HCl in the 250, because we originally made it up to 250. But you're not going to titrate the whole 250. You'd either need 10 burettes full of HCl, or you'd need an enormous burette, which would be completely ridiculous. So we want the moles in 250. So all we need to do is get rid of one of the zeros, multiply it by 10. So now it's 0.09894. Nearly there, nearly there. We need an equation that has MR in it. And the only one we know, just moved over to the right there, is M over MR. What do we know? We're trying to find the MR of this salt. Do we know the moles? Yes. Do we know the mass? Yes. It gave them to it there. That needs to go into grams. But we need to rearrange this as well. So we want MR as a subject. So all you need to do is swap over the MR and the N, effectively. So now we want the mass in grams. So we divide that by 1,000, 1.464, and we put that over 0.00984. Let's work that out then. That should give us our MR for the hydrogen carbonates. 1.464 divided by 0.00984. That gives us 148.7. Well, it does if I put the numbers in right. Let me just check them. So 1.464 times 0.009894. I think I've missed something out there, haven't I? That should be a 9 there. And when we do that, let's work that one out then. 1.464 divided by, this time it's 0.00989. 147.9. So we'll round that up to 148. That's the answer to the question. The MR is 148. If we wanted to, we could work out, sorry, it's the hydrogen carbonate, isn't it? So we could work out what the metal is actually. So what does that add up to? We've got HCO3 minus. This isn't part of the question, this is just an extra. So you've got carbon, you've got hydrogen, you've got 3 oxygens, that's 48. We add those up, it's 11, 61. 61. So we do 148 minus 61. That should give us the atomic mass of the element. And it comes out at 87. That's just a little extra. I think that's francium. I don't know. I think it's francium. But that's the answer. It's 148. Just to show you the rest of the question, because we didn't look at the rest of it. They asked us to calculate the moles. Then they asked us to do something else. Let me just go back. That's something silly. What did they ask us to do? Work out the average titer. Find the moles of HCl in 25. Find the moles in 250. And then find the MR. And it was 148. And we did it to 3 significant figures. Because if you look at the question, everything else is in 3 significant figures. So it would be a bit silly. There's something in 4 significant figures. But that's the only thing that's in 4 significant figures. So there's no point in putting the answer in 4 significant figures. Because that's not, and most importantly, the titers are not. And remember when I said, don't write 9.7, write 9.70. That keeps in mind that you are dealing with 3 significant figures. Right, that's it for this video. I hope it was useful. It would help me a great deal if you would click the like button for this video. I would appreciate that. If you don't like the video, well, I'm amazed that you watched it this far, and there's no point in watching any others because they're all like this. So don't waste your time. And thank you for watching, and I hope to see you in the next one. And when I work out how to stop this recording, we'll all be happy, won't we? Okay.